So this is Data Lake Design Patterns. I'm Jason Horner. You guys know that you're at SQL Saturday LA Virtual. It's abstract. We don't need to go over that. Welcome, everyone. A little bit about me. So I do some consulting, primarily around Azure and modern data warehouses, Synapse, those kind of things. Also have some certifications. Still an MVP at least for another month, so that's always good, I guess. I don't know. What we're going to go over today is look at some of the key data lake concepts. What is a data lake? Why would you use it? Look at some data sources and types, file formats and zones, and then cover some MPP architectures, massively parallel processing. So I'm going to try to get through this pretty quickly. Sometimes I kind of ramble a little bit here. The key takeaway is that there's so much emphasis on data these days. It's kind of the new currency, and a lot of organizations traditionally haven't managed their currency very well. So when you have a small amount of money, you can use something like a wallet, right? When you start getting more money, you can put it in a safe, right? And when you have a lot of money, you got to start putting it in a bank. And the data warehouse, in my opinion, the data lake, in my opinion, is really that kind of enterprise grade bank where you can store lots of data, right? And so that's kind of the takeaway here. Why is it so important? Well, one, it's the biggest benefit is it's schema on read. You can just dump data into the data lake and access it, right? You don't have to think about designing, tables and schemas and things like that. Now, that does lead us to an anti-pattern, right? If you just dump data in without any regard to quality or consistency or organization, you can create what's called the dreaded data swamp pattern. So you've got to be careful with that. But the idea is that, as soon as you find out, like, let's say a new REST data source or a file source or any of these things, you can just start putting in the data lake. You don't need to spend a bunch of upfront time analyzing that data before you can start kind of getting value out of it. There's some key kind of storage requirements. So you want the storage to be very scalable. You want it to be fairly infinite. You don't want to be, waiting for disks to deploy, those kind of things. You want very good cost, or low cost. And it needs to be highly performance oriented. So ideally, you want the storage performance to scale linear. So, if I'm working with, let's say, 100 meg file, I should see linear performance improvements as if I'm working with like a gig, 10 gig, 100 gig file. So I want to see kind of that linear scalability with the data. Some other things to kind of think through is it needs to be interoperable. It needs to work with many different sources. So things like Power BI, things like, Dustin had a session earlier where we talked about some of the Spark solutions out there, like Azure Databricks, Kafka, those kind of things. You need to have connectors to it. Obviously, it's got to be very efficient and fast and support different access patterns, and we'll talk a little bit more about that. And then secure is kind of a thing that is kind of an afterthought, but you want to be able to have fine-grained security over the files in the data lake, so that people can't overwrite stuff or either inadvertently or on purpose, right? And only people that should have access to certain data sets should be able to see it. And then some form of role-based access control, so you're not managing at the user level. You can use things like groups and those kind of constructs to manage the data. And then it's got to be manageable. So some kind of scriptable API, ideally, perhaps like a Python API or a CLI or PowerShell, C#, but those kind of things. As far as what your options are, this is primarily we're going to focus on Azure. So the first thing that a lot of people kind of start with is Azure Blob Storage. So this isn't an ideal approach. I'm going to kind of skip through some of this. It's lower cost, but it's an object store base. That means it has a flat structure. It means it doesn't know about things like folders and files. It just knows about URLs. And so one of the key drawbacks of using Azure Blob Storage for a data lake is you can't simply move or copy files. You have to actually, we can copy, but what you have to do is you have to actually say, I'm going to go create a new version of the file at this new resource location, and I'm going to go delete the old one. So the copy of operations or file moving operations aren't that efficient. It's optimized primarily for unstructured data sources, things like videos and images. Obviously, like the Azure storage runs on top of this in some shape or form. It's lowest cost. It has different levels of tiering. and it's obviously very redundant. You can choose that level of redundancy that you want, so you can have it locally replicated 3 times within the data center. You can do that across Azure regions, which gives you the global redundancy, or across zones. So there's different levels of redundancy. Obviously, you pay a little bit more for each of those. So it still can be a good option, especially if you're dealing with like ingesting a lot of, as kind of like a front door for ingesting a lot of smaller files. It can be part of your data lake, but I wouldn't probably build a data lake today around that. Kind of a legacy approach is this Azure Data Lake Gen 1 storage. It was kind of their first approach at it. It had, so one of the things that Blob storage didn't give you was the ability to have those POS examples and Azure Active Directory integration. You could use shared access signatures, but that was it. So you didn't have that level of control of security. A little bit more interoperability here. It was optimized for analytic workloads with no file limits, file size limit, whereas Azure Blob Storage, I believe, had a limit around just under, is it under a terabyte, I think? Might be a little bit more these days. And then you have a folder structure, right? That's really the other key difference, is that you can copy things around, and you're not doing, copy and then delete patterns and things like that. So, however, Microsoft came out about a year ago, a year and a half ago. They came out with Azure Data Lake Gen 2, which basically takes all the good things about blob storage and all the good things about Data Lake Gen 1 and rolls them into a single thing. So you have that hierarchical namespace, the ability to have folder structures and atomic file operations, improve performance, so it's geared towards analytical workloads. But you also have the flexible pricing, the ability to tier the storage, and it's got deep integration with all the major MPP engines through either Microsoft provided drivers or open source provider drivers and authentication schemes. So this is, if I was going to build a data lake today, this is probably the first place I would look. And just a little note on the architecture. One of the key things about ADLS Gen 2 is you can interact with it with one of 2 different protocols or APIs. You can use the legacy ADLS API, or you can use the Blob API. And so it gives you kind of the best of both worlds there, as far as being able to do administrative options, as well as kind of, connecting it to analytical data stores. And then all of those capabilities obviously are just built on the Blob storage layer itself, right? So the ability to do your HADR, your AD integration, your object tiering, and lifecycle policy management is all underpinned on this. So whereas in Azure Data Lake Gen 1, you didn't really have that, okay? So a couple things, there's really 3 fundamental types of workloads in the analytics space when you're thinking about storing data in data lakes. So the first one is batch, and this is kind of the traditional ETL or even ELT data flows. So every hour, every day, nightly, whatever, you're processing that data kind of in a kind of a large batch oriented manner, and you're dumping the data. So that as time goes on, so whatever that cadence is, if it's weekly, if it's daily, if it's hourly, you're going to process that data, right? Now, when you start talking about some of the streaming real-time kind of patterns that you see out there, you have Microbatch, which is what Spark uses. And that's where it's going to take the data in very, very small increments. So it looks like it's coming in real time, but it's still fundamentally a batch technology. Other services, such as like Apache Storm, are actually true streaming platforms where when that, or Stream Analytics, is when that data arrives, that's when you're actually going to have access to that data. So if you need to do, like, let's say, for example, you've got some IoT scenarios where you're pulling metrics off of like a building HVAC system, and you need real-time kind of computation, then maybe something like Storm or Azure Stream Analytics is more appropriate. Databricks can certainly work for that, but it's really kind of a bit more of a hybrid. It's like a low latency kind of batch is what I would characterize it as. And then you have different types of data providers. So structured data providers, everybody's going to be familiar with these. Things like SQL Server, Postgres, MySQL, standard relational data source providers, right? And so the idea is that you would use some process Could be an ETL process, could be, you know, a cron job, could be whatever, to pull data out of here and to bring it into your data lake. You also have semi-structured data providers. So these could be things like Cosmos DB, it could be Azure Functions, REST APIs, or web applications, or custom applications where you're pulling telemetry out of those data sources and putting it into your data lake. And that could arrive in real time, like it could be the function, for example, could write directly to the data lake, or it could use something like an event hub or some other technique to kind of queue up that data, or write it out maybe in batch. And then the final type of data source is true event type data. And so you could pull data from Event Hub, Apache Kafka, IoT Hubs, or Azure Stream Analytics, right? So all of those platforms have the ability to write data out to a data lake. Or for Stream Analytics, for example, you can write a query, and the results of that query can, like say, every 10 minutes be dumped out to the data lake. So a lot of different options there for processing data. And as far as ingesting, you can use Azure Data Factory, you can use SSIS. If you're more in a traditional kind of Hadoop world, you might use DistCP, which is a Hadoop-based tool for copying data. AZ Copy would be kind of the equivalent of that on the Azure environment. Scoop is a kind of a Hadoop ecosystem ETL tool. And then there's other third-party tools out there like Talon, Matillion, Fivetran, Airflow. So there's definitely other options besides just using Azure Data Factory, which a lot of people do, or, you know, for example, Databricks, Spark, those kind of things. As far as data types, I look at it from this lens. So structured to me just means relational. It's a tabular data set that I'm pulling out of a relational database. It could be Oracle, it could be Postgres, it doesn't really matter. Semi-structured to me, so I really think that all data inherently has some kind of structure. But when I say semi-structure, it's still kind of tabular. So for example, CSV is kind of a tabular format, although there's, well, there is an RFC out for there, but there's not a formal CSV spec. JSON has structure as well. XML is structured, although kind of the main difference between like JSON and XML and CSV is they can have hierarchical nesting, which can make processing those data formats challenging for certain ETL tools. And then you have your binary or unstructured, and those could be things like, you know, Excel files. So one really cool thing is Data Factory just recently released support for working with Excel files. So that's pretty exciting for a lot of folks. Prior to that, you didn't have a lot of great options for processing true Excel binary files. But even imagery data, so things like JPEGs or PNGs, where you might be using that data, running it through cognitive services to do image recognition or feature extraction, those kind of scenarios. And then same thing with textual documents, right? So you might need to parse a bunch of resumes and look for keywords, right? And store that in a data source. So that would be a good example for using a data lake. Or you might get PDF order invoices, and you're pulling out pieces of the order to store kind of in a structured format. So those are obviously all different types of sources that you could have. And then as far as for how you actually are going to store that data in the database, you have those options, but then there's some other formats that we're going to look at here, like the text and the big data formats. We'll talk about kind of the pros and cons of using all of those. So text is human readable. There's not really a standard encoding. You know, you could say CSV, delimited, right? Those kinds of things. But there's different kind of nuances that come up with text files. Obviously, things like line endings and encoding and byte order marks, all those things can make working with text kind of challenging in certain environments. But it is well supported, right? There's lots of different drivers that support working with that. By default, it's not going to be compressed, right? So it's not going to be the most efficient type of data to store for analytics, but it's human readable. So, you know, it helps with debugging that data and being able to look through the data as you're developing to be able to kind of help debug things, right? So that's an option. JSON, so a lot of sources like REST APIs support JSON natively. So a lot of people will just take that JSON stored in the data lake. It's very interoperable, but like I said, it has that complex nesting, so multiple levels of object and array nesting. It's still human readable, right? to some extent it's self-describing, right? There is kind of a schema there, but if you don't use a compression, it can have extremely large files, and depending on how that JSON is structured, it might not be splittable, which we'll talk about later, which has some impacts on performance. Okay, Avro is another file format. This is the language that like Kafka and some of the other message-oriented processing use. It's a JSON schema with a binary file, so you can't just read this directory directly. There are libraries out there for reading Avro files. The main claim to fame with Avro is it supports this concept called schema evolution, which is the notion that I'll define a schema, and then if that changes over time, I can define a default value in case that value isn't present. So it handles those kind of changes. So if you have a data source that's going to change very wildly over time, or kind of 2-3 times a year, if it's going to continue to get update, you might want to use Avro, although it's not a great analytical format. So oftentimes you'll use one of these other big data formats I'm about to talk about to use it. So ORC or ORC, that was a product that came out of the Hortonworks. It's a columnar format. It's optimized for analytics, so it supports things like column-based compression, segmentation of the data so that you can skip rows, or you can scan rows very efficiently. So there's the ability for predicate pushdown. And then on top of that columnar compression, you can put additional compression on top of it. So it's interesting because the other format that you typically run into that's columnar based is Parquet. And so a lot of times people will ask, well, which one's better? And the answer to some extent depends on which underlying services that you're using. So for example, Cloudera, I think, has kind of favors Parquet. So on those distributions, Parquet is going to be faster. On the Hortonworks distribution, which is now not really a thing anymore, ORC could have been faster, right? So one of the big things that I would recommend doing is, before kind of settling on one of these, definitely do some testing, especially if you're not kind of using one of the common like Azure services or Databricks. With Databricks, I would say Parquet is probably the fastest and gives you the best compression. So that probably is kind of the default for most data lakes these days. Although one thing I will say about using Parquet is if you're not gonna use it for analytics, so kind of running multiple queries over that same data repeatedly, if I was just gonna write it out to Parquet only to read it, maybe for staging purposes, it will give me the compression, but that writing is going to be slightly slower because it has to do all the mechanics to get the compression going, right? So it might be faster to, for example, just write out a compressed CSV file and load that. And then there are some splitability things that we'll talk about later. So it's not always important, but when you're dealing with large amounts, terabytes of data or larger, it's very important to kind of test the different formats just to validate your assumptions. So Parquet is going to read very fast, but it's going to generally have slower writes. And same thing with ORC. And then a relatively new thing is this Delta Lake. So the idea here is that it's basically trying to duplicate kind of an underlying relational table. So under the hood, it's using a Parquet file and a write-ahead log. It gives you the ability. So one of the problems with using a Parquet file is if I get data, let's say I get data that's coming in a stream, and let's say I have a file and then I want to append data to that, there really isn't a good way to do that in Databricks or in Spark. So what I would have to do is either write out the new data as a separate file, or write out the old data and combine it with the new data into a single new file, right? Or into multiple new files. So those are kind of the patterns. And then if I needed to update data, let's say I have a 10 gig file and I need to go in and update a bunch of data in, let's say, a certain row, I'd have to actually regenerate the whole file. So what Delta Lake really gives you is the ability to do those updates across the tables and to insert data. It also gives you time travel, which basically says I can run a query across this data as of a certain point in time and see the data how it looked at that point. And then it gives you a bit of schema enforcement as well as evolution support. So Delta Lake's starting to get, it's an open source project now, so it wasn't always that way. It was part of Premium Databricks originally, but they've open sourced it. So you're going to start seeing that kind of become more of a de facto standard for data lakes. I still, in some cases, will just use Parquet, but most of the time I'm going to use Delta Lake as my default storage for a data lake. And then just a little bit of a high level of kind of Lambda architecture. It's relevant because to me, I really think of like the primary use case for using Delta Lake is when I do need to have a hot path in a Lambda architecture. So I've got streaming data coming in, so I'm constantly inserting into that Delta Lake, and then the query process needs to see that data kind of in near real time. Whereas if I was just doing batch processing and I'm just writing that data out once and I don't need to necessarily update it, I might be okay with just using Parquet. So there's other patterns as well. So Lambda's one pattern, there's Kappa pattern, which we don't have a lot of time to talk about. It tries to address the issue of having the same data in streaming as you have in batch, can lead to some kind of inconsistencies in your data, right? And so Kappa says just treat everything as a stream, basically. So you kind of have fundamentally what looks like a log, forward only set of data, and just run that through streaming and then build batch processes off the top of that. Anyway, so one of the major concepts, in fact, probably the biggest thing you have to pay attention to besides the file format of how you're going to store the data is designing what's called zones. And zones are a really simple concept, but I see a lot of people get them wrong. So what zones are basically folders inside our data lake, okay? And so this is an example of some zones. I'm gonna spend some time talking through this, and then I've got some slides with the textual talking points that I'll probably just kind of skip through in the interest of time. So starting from kind of how the data comes into the data lake, some data lakes will need what's called a landing zone. And the use case there is really, if I have third-party people, that could be people on other teams internally, or it could be external partners, if they're responsible for putting the data in the data lake, or they're producing something to hand off to me, I may not want them to write directly into my data lake. So I may create an external landing zone that could be something very simple like an FTP server. It could be a Windows file share. I've seen both of those things being used. It could be an NFS mount point. It could be an Amazon S3 bucket. But the idea is that they're able to control their process to dump the data out into this landing zone. They don't have rights to my data lake, and in fact, my actual data lake may be in a private VNet. So I have a layer of security there, but then I have control of when I want to go grab that data. So my partner might be producing the data, let's say, 3 or 4 times a day, but I only may need the data once a day. So I may just let that data kind of batch up in the landing zone, and then I may go have an ETL process that goes out and grabs all the files in the landing zone for the current day. So it kind of gives me a little bit of a separation and a decoupling between the people that are producing the data and then me as a consumer of that data, okay? So usually and I'm not always saying, or I'm not saying that you always need a landing zone. It's just something to think about depending on what your requirements are. Typically from there, it'll go into what we call a raw zone. Raw zone, the whole concept there is the data is immutable, meaning it's not going to change, and I'm just going to write new data. Now, if I'm using Delta Lake for my raw zone, obviously I can append and I can update that data, but ideally I want to keep that raw data as close to how it's coming in as possible. Now, some caveats there would be, let's say I have a third-party partner that's zipping up the data, or they're encrypting the data. I would obviously, in my ETL process, I would unzip it, unencrypt it, perhaps like combine or break apart the files. But fundamentally, I don't want to change that data. And the reason is because I don't know when I might need to go back and actually get that raw data. So today, I may only be pulling data from like 7 or 8 columns in like a given CSV file, for example. But tomorrow I might need to find out that, oh, I need to go and grab this customer name field too, or something like that, right? And so it gives me the ability to go back and reprocess that data, where I may not even be able to go request it back from the source system because the data as of that point in time may have changed. And that's really the benefit of the schema on read, right? And so since the Delta Lake gives me that time travel capability, I kind of can kind of meet the requirement of the immutability in the raw zone, okay? Now, if I have data, let's say the data is coming into me in the raw file format is like let's say a custom EDI file format, something that has some nesting in it, and it's very cumbersome to work with, and I've got to do some custom parsing. Oftentimes you might be working with a data feed where you're using a bunch of regular expressions, for example, to parse the data, or you might have nested arrays that you need to kind of pivot or explode. In that case, the typical pattern that I see used is to introduce what's called a structured zone. That structured zone would kind of store that in kind of more of a tabular format. It might do some data transformations, so it might kind of sharpen the data types, so convert strings into dates or into integers, those kind of concepts. You might implement that as a Hive meta table inside of like Azure Databricks, for example, or it could just be a Parquet file in your data lake. So you've got some options there, right? Then kind of two what I would call more kind of optional layers would be stage and temp. So stage would be an area where I would be producing data that's going to be kind of prepped and loaded into either a downstream data warehouse or some other consuming system, right? It could be Cosmos DB, it could be an event hub, it could be a lot of different things. But the idea is that that staging area is kind of like the staging area in my data warehouse. I'm able to take data out of raw, the new data, manipulate it, cleanse it, transform it, enrich it, and then store out just the current snapshot of that data into stage, right? So it's all about setting up an efficient load process for my data warehouse, okay? Temp is kind of that same concept. However, and then the other thing too about both of these, generally speaking, although stage, you can make an argument that you don't have to do this, but I would say that they're ephemeral, right? Once I've loaded that file, I'm going to delete it, right? I still have the raw data, so I could potentially recreate it, but these are just working spaces. Now, you can make an argument that you want your stage data to be kind of kept for perpetuity or for a month or so, just for troubleshooting purposes or for doing reloads. And the key thing to keep in mind is the data lake storage is orders of magnitude much less expensive than like a database service like Azure SQL DB or a Synapse SQL database or even Cosmos, right? It's very inexpensive. So we don't need to worry about storing multiple copies of this data. With temp though, we have this problem called the small files problem, which let's say I'm getting kind of trickle feeds from, let's say it's a website, and every time a customer let's say I'm a car dealer, and every time a customer fills out a form, a contact me form, I'm storing that in my data warehouse, right? And so and let's say I'm getting that data as JSON and I'm storing it in the data lake. So I have this app, it writes the JSON data out. I put that data into temp, or maybe I keep it in raw, and then I can combine that data or vacuum that data and create a bigger, kind of larger file that's more efficient to deal with, and then use that transform result to either store in raw or to move it into curated, right? So it's very similar to stage, but the intent there is a little different. Ref would be kind of an area where, let's say I get like yearly or monthly updates from kind of a data source that doesn't change very often. Could be a date table, could be a list of cities or states, could be a list of stores. This would be traditionally where I'd put like my master data, right? So I could put that in the ref zone. My curated zones are going to be zones that are geared towards consumption. So if I'm going to put Power BI or data scientists directly against my data lake, I'm not going to let them touch my raw zone or my structured or my stage or my temp. I'm going to make them use a curated zone so that I can kind of cleanse and enrich the data, prepare it, and give them exactly what they're requesting, right? So it's a way of kind of organizing it and making sure that they don't, for example, have access to manipulate data inside the raw zone, right? I don't want them to delete files, things of that nature. And then I might have compliance or other requirements where I need to archive that data out. And so I can use this archive zone to move data out of the data lake from either the raw, so it could age out, let's say contractually like every 7 years, or I only want to have 7 years of data within my data lake. I may move out data that's older than 7 years into archive. It might go to slower storage. So I could use the cool storage tier for that. Or it could be kind of the last stop before I delete it, or maybe that archive location is a backup, because one of the problems or the challenges with data lake is there's no Blob storage has a concept called soft delete, where if I delete something, I can turn on soft delete and it never really goes away until I clean it out or have a policy on it. Data Lake Gen 2 doesn't support that currently. So if I'm protected against what I call physical corruption, meaning that you know, the Azure storage server loses a disk or something like that. I'm protected because I've got multiple copies of that data, and that's all transparent to me. But I'm not protected against user error. So if I, as a data engineer, write this whiz-bang Python script, and at the end of the Python script, I delete the data that I was working on, but I found out later we needed to keep it, it's gone. So what I can do is I can put a policy in place that kind of does this backup to protect us against logical corruption or deletes, right? So we had a situation where we were working with some POS data, and one of our ETL developers deleted like the last 2 weeks worth of POS data. Luckily, they were storing it somewhere else, so we could recover it. But if we weren't, that data would have been gone, right? So you want to make sure that you come up with some kind of a data archive strategy. I think there are some third-party tools out there that can solve this, but there's nothing within Azure that says, hey, replicate this to another Blob storage account or replicate this to another data lake, right? So I'll just, you know, this is just kind of what I just walked you guys through. So landing zone, again, it's when you have data that's pushed from a third party, you don't always need it. And the key thing that this enables is it enables your data lake team to have more control of the ingestion cadence or timing. Okay. Raw zone, there's no transformation, data is immutable. We'll go into the structure of these, but you're going to want to, inside your raw zone, you're going to want to have it sorted out by source system and schema, and use files for that purpose, because the key concept of working with kind of big data systems is you want to be able to just point the process at a directory and not have to do filtering inside of that, right? You just want it to be able to work against those files. So a data swamp would be where you're putting Excel files, JSON files, Parquet files, all sorts of different schemas and columns under a single folder. And now you've got to write logic to separate out the data that isn't going to match up, right? And you don't want to do that. If you have very large data sets, you're also going to want to probably partition it, usually by modified date, perhaps by create date. The idea there is that some engines can take advantage of those partitions. So if it knows that your folder structure is, you know, year, month, date, and you run a query for just June, it's just going to scan the files underneath that June 2020 folder. Okay. The problem with this is it assumes that you're doing incremental loads, right? And that's not always feasible. Sometimes you have to take an entire snapshot, and that's where you could use the temp table pattern. Bring that historical snapshot, so the full data out of your source system, put it in the temp zone, and then in Python, right, or in PySpark, write a full outer join and work out what the deltas are, perhaps using a hash key or some other approach like that, and then take that resulting delta and write that out to your raw file or raw zone, right? So that way you're not duplicating all of that data that hasn't changed, right? It's surprising actually how many systems I work with or I come across where the #1 challenge we face is the source system doesn't have a reliable way of incrementally detecting and presenting changes to us. And so we spend a lot of time trying to optimize that. Structured data, so it's where we're going to sharpen our types and take data that's kind of semi-structured or unstructured and moving it into kind of a more structured format like a CSV or a Parquet or a JSON. And it could also be raw audio files. So we might be taking an audio file and trying to run it through cognitive services to turn that into actual text, or we could be transcoding video frames, right? So we did some work with a bank that's actually pretty popular in the LA area, where they had a live security feed of employees coming in and out of the building. And instead of making the people scan their badges, they wanted to use facial recognition to detect the employee. And we put machine learning on top of that to flag somebody that says, oh, this looks like somebody that shouldn't be here, right? Or this is kind of an anomalous entry or exit. So the ability to do that. And so I think you're actually seeing a lot of interesting things specifically around that facial recognition technology and kind of the social impacts around that today, but it was kind of an interesting project. The other key concept here is we're not doing filtering or enrichment per se, right? So I'm not removing data out of here. Generally, I'm not enriching the data, although potentially I could be adding some attributes, I guess, if it was audio or video or something like that. But generally speaking, if I'm enriching data or filtering it, I'm using a curated zone to do that. right? And those aren't hard and fast rules. Those are just kind of, it's kind of like it's up to you to kind of prevent this data lake from becoming a data swamp, and how much thought you put into your folder structure and enforcing the consistency across different ETL teams and across consumers, you're going to have a much better and more usable data lake. Right. I think one of the problems was initially when this pattern was first introduced, everybody jumped on board and said, well, let's just create a data lake, right? And so they just started slamming data in there without any kind of thought to it. And I think that caused a lot of data. There was no kind of thought of like, how are we going to use the data, or, you know, is it even accurate, right? And I think that was problematic for a lot of older data lakes, right? So always spend some time designing these things correctly up front. Stage, so we talked about that. The key concept here is that files might be regenerated nightly or weekly or hourly, whatever the cadence is. It's about prepping the data to be loaded into a downstream system. Whereas the temp zone is about doing things where I might need to work out deltas. I might need to do that kind of fix the small file problems where I need to vacuum or archive it. The needs for using these temp spaces are a little bit less now that you have Delta Lake, but prior to Delta Lake, having the space for temp made a lot of sense. As far as curated, that's where our enriched data sets, the stuff that we're going to expose to our end users. You know, the data is blessed. Ideally, there's some data governance around that, right? So everybody has access. And the structure of this zone is going to vary to the extent that your use cases are, right? Whereas the other ones are pretty cut and dried of how you set them up. The need to have this, or how you put folder structures underneath that, is going to be kind of more, the onus is going to be on you guys to decide how you want to design that, okay? And then archive, that's just where we're removing the data before we age it out, okay? We talked a little bit about subsystems in our raw, and we could have subsystems in any of the zones that we needed to. So in the raw zone, it might be actually my source systems, right? So let's say I have a SAP database, a JD Edwards database, and a Dynamics database. Those would each be subzones or folders. And then within there, let's say I'm grabbing the customer master out of each of those, I would create another subfolder for the customer table and the address table, and so on and so forth. And then if the volume warranted it within that, I would partition it out by year, month, or date, possibly location, or maybe both time and location, depending on what types of analytics. So I've done a lot of work for manufacturing companies where they had global presences. So, you know, think, you know, 15, 20 factories or manufacturing locations around the globe, and they wanted to kind of segregate that data off by location as well as by time, right? Sometimes you'll create a subzone for users. So you might want to give the user a sandbox area to play with in the data lake. So that's a way to kind of keep them out of the other areas where they can kind of create files, delete files, have more full control than what you'd be comfortable giving them in other regions or other zones inside your data lake. And so we talked about reference a little bit, sandbox user, kind of the same concept there. Zone alternatives. So spend a little bit of time on this because I think it's important. So the design I just showed you with those kind of canonical zones, that's my preferred approach. I know, like, if you read through the Databricks literature, they have this concept of bronze, silver, and gold, which I don't like. I'm not a fan of it. But the idea is that as you enrich the data, it goes from bronze to silver to gold. I don't think it's meaningful to people, and I don't think it gives you enough structure and control, but it certainly can work. Another thing before I get off the topic of zones is you're starting to see, like, for example, Databricks has introduced their data lakehouse, and then just recently Snowflake has kind of said, well, you don't need a data lake anymore because, holy cow, it's raining really good here. Because you can just put all your data, whether it's structured or unstructured, right in Snowflake, and it can be the single source. But I would push back again.
Jason?
Yeah, go ahead.
Sorry about that. I have a question over here. It says, what is the major difference between stage and structured zones?
Oh, yeah, good call. So let's take a look at that one. So the major difference is structured. I'm primarily going to, now I should have said this, I'm not always going to have a structured zone, right? So I would only use a structured zone. Let's say that I get a file in an, I'll pick on XML. It's probably not a great way to do it, but I'll just say XML. So I get this XML file, and let's say it's hierarchical, it's very nested, and it's not really something that like I want to deal with in my ETL maybe necessarily, or it's not in a great usable format. What I would do is I would maybe store that XML in its raw format in the raw zone, and then I would take that XML. I'm not gonna filter things out of it, but I'm gonna flatten it, right? Or I'm gonna pivot it, or I'm gonna explode it. So I'm gonna kind of reshape that data, and I'm gonna sharpen the data types, right? So for example, JSON has some data type support, but it may not match what you have inside of a Parquet file, right? Or other things. If I get data in a CSV file, all that data is inherently string, and I may want to store that data as an integer in a Parquet file. So the structured zone is really my chance to kind of do that kind of second tier level of staging if I need, or not staging, of saving the data to make it kind of more workable, and make sure the data is consistent. Whereas staging is really where I'm prepping a data set to load it into a data warehouse. So in staging, I might be creating my DIM customer import. And what it's going to do is it's going to take all the new customer data that's coming in, and the existing customer data in raw, work out the deltas, right? And let's say that it's coming in as CSVs, then I might actually take that data and put it into Parquet in a structured zone, and then just grab the current either records that have been changed or new records for the customer data set, so a much smaller set of data into the stage zone. So the idea there is that I'm just prepping data for ingest into another third-party system. Could be a data warehouse, could be an OLTP system. That's kind of a rare pattern. You can kind of think of the structured zone as like an ODS in a corporate information factory model, I guess would be one way to think about it. It might, the work we're doing in structuring might be, let's say I have like 3 or 4 different manufacturing systems. I might just be consolidating all that data into a single table. So all my manufacturing output goes into one kind of file as opposed to being in 3 different files, because it's coming from different source systems. So I might be kind of conforming them. So you can start kind of thinking about architectures like Common Data Services or CDM in the Power BI world. It kind of gives you a little bit of that flavor as well, right? It's a good question though. And that's just it, right? Like this is all just in, I'll say in my head, right? I didn't make all this stuff up. I stole it from wherever I could find it, right? But these patterns have worked well. I've probably done in the last 3 years, I've probably done about 30 or 40 of these where I've been personally involved in these projects from an architectural or implementation standpoint. And our consulting team's probably done much, like twice that easily, maybe more. And this pattern has worked really well for us, from designing a data lake and having a data lake that people can come to and self-service directly from, so they can put Power BI on top of that or Tableau or whatever they want, but they can also use this as a source for the data warehouse, right? But it's really up to us as architects or engineers to build these out, and make the zones consistent, because at the end of the day, all they are folders, right? And so just back to that point, so there's different ways to lay out the zones. You could create whatever zones you want. If you want to create a zone called carrot, go ahead and knock yourself out. Like, as long as it means something to you or to your business, then that's fine. Where I was going with the Snowflake thing is their approach is we don't need it because I can store structured data and I can store unstructured data in Snowflake. And I don't accept that. I don't think that's a good approach. I think using this very cheap storage for storing a variety of data types, both structured and unstructured, is really a good pattern and works for a variety of different use cases, whether that's analytical workloads, operational reporting, data science workloads. It's kind of a lowest common denominator, and as long as it's underpinned by something like Azure Blob storage, it meets all those storage criteria that you need from a data lake, right? Whereas if I do that I'm not saying Snowflake is bad, right? I'm just saying I don't buy using Snowflake for the entire data warehouse or for the entire data lake, right? I think it makes a great data warehouse, makes great for data marts. I don't think it's a replacement for the data lake. And where Databricks comes at it is with this lakehouse pattern, right? Which I think is garbage as well, which basically says, you know what, just put it all in Databricks, we'll sort it out, right? But I think that can be expensive, right? So I love Databricks for doing machine learning at scale, and I love Databricks for doing complex ETL kind of transforms, data engineering workloads, running pipelines. But I don't think it's a great for highly concurrent analytical workloads, right? So if you think back to like SSRS reports for like maybe a telco company, right? So you've got, you know, thousands and thousands of people in the call center that are running against these reports to get customer activity or some other kind of thing, right? It's Databricks, in my opinion, isn't going to scale for that. It's got the ability to kind of auto scale and do those workloads, but I don't think it's as efficient as, say, a scale out SQL Server or even Synapse, right? I just don't think it's a sweet spot. I think when I go to use Databricks, it's primarily either for data engineering or data science, and I don't view it as a great data warehouse workload. It can be, I just don't think it scales to highly concurrent workloads. So that brings us into kind of this MPP talk. And so use SQL, Azure Data Lake Analytics, that's kind of deprecated. So I probably should update that slide. Hive would be another one, that's the little B there. SQL Data Warehouse or Synapse. So it has the ability to run MPP, which basically you have a master or a kind of a leader node, and it can dole workload out to the worker roles or the executors. And so the idea is you're taking advantage of multiple processors on multiple boxes, and then Databricks, right? So Spark. So those are all kind of MPP engines, whereas Spark tends to be kind of more of a big data engine. SQL is kind of more SQL DW, or Synapse is more like a Netezza or a Teradata, where it's a traditional SQL data. It's SQL based, right? And that's not to say that Databricks can't run SQL, because you can use Spark SQL. You can even use PySpark to call Spark SQL inside the same notebook, right? So that it's a little bit of a blurred line there, but I kind of view that this as there being a little bit of a difference between the two. Getting into the patterns, key things that we need to look at: how do we name the files? How do we partition them? And then we need to understand the trade-offs with compression and splitability. So for file naming, I like to make sure that I'm always encoding the data source and the time into the name. So you can see here that this is from a table called sales order. It's got a date of 2018, January 12th at 23:59, right? And then it's a CSV file. So I make this all consistent. A key thing to note about Azure Data Lake Storage is it is case sensitive. So you could use camel case, you could use Pascal case, you could use all lowercase, but I just make sure it's standard. Make it unambiguous and consistent. So some people will just write out like sales order, and then assuming that it's in that folder, you know that it's 2018 January 12th. But as soon as you move that out to another folder, you lose that context. And then the other thing that can be problematic is when you run an MPP job on these, you don't have as much control over the file naming, because what happens is, for example, on Databricks, it's gonna go in, it's gonna read a file, and then I can control the partitioning, right? So I could say, you know, partition by this attribute, or I could say partition it into 12 different partitions, and I'll get 12 files, and those files will be named with they'll be put into the common directory, and then they'll be named with like the process ID and probably some other nerdy stuff, and so you don't have control of it. But what you can always do after the fact is go through and rename them, or if you don't want them to be 12 different files, you could always run another job that concatenates them out into one, right? So you've got some options there to clean it up. Generally, I wouldn't mess with it a whole lot, but if you wanted to, for example, you needed to do that for your staging layer or something, you could certainly do that. The key thing here, though, is naming things consistently helps with self-service and helps you find data so that you know exactly what's in a file. We talked about partitioning, so that's this concept of I've got my raw zone, it's coming from an InventureWorks database, it's the sales schema, and it's a sales order table, and it's 2018, so year 2018, month of January, and the 12th day of the year. So I don't always need to go year, month, day. Sometimes I might need to go deeper than that. Sometimes I might need to say, you know, partition it at an hour level, like if it was telemetry coming off like an HVAC or a manufacturing system. If it was data coming off of like a business system, I may only partition down to the month level, right? So I may have 30 files or 31 files in a monthly folder, or I may create the files per day. It just kind of depends on how I want to optimize it. So typically speaking, you generally want to have it in kind of reasonable chunks of data. So the more chunks of data you have the files in, the more efficient generally the ETL or the loading processes will be. Some processes can split a single file and work on it in parallel, depending on some attributes. That's where we talk about splitability. But ideally, like, and the exact size really kind of depends on what the system is on top of it. So you might use something different for a Cloudera Hadoop cluster than you would for a Databricks cluster, for example. Generally speaking, I would say around 256 megs is an ideal size, but that's going to change based on how much data you're working with, right? So if I'm working with 100 terabytes of data, obviously 256 megs is too small. So I might look at dumping them out into chunks of like 10 gigs or something like that, right? For optimal analytical processing, right? Not how I store it in the staging data or in the raw database, but how I put it in the curated zone. If on the flip side, I have a lot of small files, well, maybe putting them in a 256 megs, maybe that's too big, and maybe I need to split it up into slightly smaller, right? But there's a point of diminishing returns where I might have, for example, a bunch of like 10K files. Well, that's not going to be efficient because the overhead of reading and opening all those files, and even just scanning, like you might have thousands and thousands of files underneath a single folder, is going to overwhelm the MPP system. So you got to kind of balance the number of files and the size of the files so that it's reasonable to deal with. And generally speaking, you don't want to create a bunch of empty folders or files, or mix different types of files within a folder or hierarchy. So I wouldn't want to put underneath that AdventureWorks folder, I wouldn't want to put sales order files and sales or customer files, for example. I want to keep those in their own zones. And I don't want to have a bunch of empty folders. What I could do, but the problem there is, how do I tell if the job ran? So if there's not a folder for the 12th, did it not run, or was there not any data? So that's where I would go back to my auditing system and verify it from there. I don't need to write out a bunch of empty folders. It's not efficient. Splitability is kind of what I was talking about. In some cases, like for example, if I have a JSON file that has multiple rows in the same object, it's not going to split, meaning I can't parallelize that file load. Now, if I have one JSON record per line in a file, it's splittable, assuming it's not compressed. Some compression is splittable, other types of compression isn't. So this is just something you kind of have to work out and figure out how you're going to store the data. And there's always a trade-off when dealing with compression, right? So sometimes you want to use a compression because you're going to reread that file many times in your ETL process, so you're going to save yourself some processing time. Other times you don't want to compress it because the overhead of writing the data out and compressing it is going to negate the benefit that when you're going to reread it just one time, right? And then just note that some columnar formats have their own internal compression that's outside of actually compressing the file. So testing is the best way to do that. And then just an idea, anytime you're compressing data, what you're basically trading is CPU time for storage or network IO bandwidth, right? Columnar formats. So these are really good to use if you're going to query the data multiple times. Obviously, if I'm just writing out data for staging, maybe Parquet isn't the best answer. Maybe just writing out a CSV file can be more efficient. So that certainly was the case with Azure SQL DW, where Parquet file couldn't be split. So SQL DW or Synapse has, I think by default, 64 or 80 parallel readers that can use at one time to pull data via Polybase. It might have changed recently. And so the idea there is, if I have a 100 gig file, I could operate on that in parallel with 80 different threads to load the data efficiently. Whereas if I just had a 100 gig Parquet file, only one thread would be used to read that file, right? They also have support for column elimination, so it's going to do column level scans. So just like a cluster column store, basically, predicate push down, segment elimination, internal compression, right? All those kind of things that you get with clustered column store are generally supported in columnar formats like ORC or ORC or Parquet. Some anti-patterns. So we talked a lot about, the bulk of this session is really just preventing the data swamp. addressing small files, and then excessive data movement, right? So data swamp occurs when you have inconsistencies in your file naming, folder structuring, file types. You don't have data governance, so you don't have a data catalog where people can go look for data and say, oh, I need to know where my CRM data is. It's in this curated zone, right? So the data swamp kind of prevents our self-service. If I have multiple file types within a folder, all those things can kind of lead to data swamp. So this is what you're trying to prevent. Small files, so when you have lots of small files, so think messages coming off of like a Kafka or Event Hub, or you know, Cosmos DB records coming from a change feed, for perhaps, all those things. It doesn't, the data lake technologies don't generally deal with small files very well. There's an overhead for metadata and management operations. So you don't want to be processing, you know, 60,000 files in a single folder. Like, that's going to get slow. And so the way to fix this is to basically write a process. So let's say you get data that's coming in real time and you're getting these little 10K increments. Then every hour you go in, batch up the files. You're not transforming or anything. You're just combining them and rewriting that out as an output, right? And then moving that into your raw zone. Okay. And we talked about optimal file sizes. And then we're coming up on time, so I'm going to kind of fast forward a little bit, try to get through all this. In addition, they're recording this, so you guys will have access to this, but I have the full recorded version of this. I've got a couple versions out there, so I got a link for the recorded session at the end of the deck. So I'm not going to talk through these. I'll let you guys read through them, but these are kind of just the key kind of common challenges you run into when you're designing a data lake. And then as far as governance, so Azure Data Catalog, it's, what can I say? It's not great, but it's almost free. It's very inexpensive, and it's reasonably good at search and discovery, right? So it helps us a lot there. It allows us to do kind of an online shareable data dictionary and store metadata and allow us to filter and search by tags. So I definitely recommend, if you're going to use a data lake, use some kind of data catalog. There's third-party software out there like Elation, Apache Atlas, I think, is another one. So there's other cataloging tools out there that you can use. The data catalog really solves these 6 challenges. So fitness, can I use the data? Is it fit for purpose? Compatibility, how do I join this data, right? Can I join it? Knowledge, who can I go? Who are the experts about this data set? Access, who can let me get into the data, right? Lineage, where does the data come from? I obviously spell lineage correctly if I were to go look at my slides again. And then quality, can I trust the data? What's the veracity of it, right? So data catalog is solving all these challenges for us, hopefully. So key takeaway from this is have a data catalog if you're going to have a data lake. And then metadata, I'm a big believer in adding additional metadata to your structured zone or even into your curated zone. When was it created? When was it processed? MD5 hash of the file. These can be stored in line with the file itself, or they can be stored in another kind of file somewhere off or into a database. But just so that I can tell, has the file been monkeyed with? Has somebody been manipulating the file since I landed it? Where did the file originate from? Okay. So I think we've got, what do we got left? We got, I think it might be at time, yeah?
Yeah,
Okay.
I didn't want to interrupt. You were doing really great.
So we're
but yeah,
so we're gonna skip through the security stuff. Sorry about that. Just that's all kind of Azure stuff. I'll show you, this is a link from the bits session that I did, and then they'll publish a link for this too. So feel free, I'm on Twitter, so you guys have my contact information there. If you guys have questions, send me an email, connect to me on LinkedIn. I'm more than happy to talk to you guys about data lakes and best practices. I'm putting data warehouses on there. What type of data warehouse should you use? Anything kind of Azure. So hope everybody took something away from this. And with that, I'll turn it back over to you, Elena.
Thank you, Jason. And I'm really sorry to all the guys who posted questions that we weren't able to get to them. I really wanted to make sure that Jason had the time to complete his presentation. And Jason, will you be uploading your presentation to the SQL Saturday website? I believe you are going to?
I will. And then also, if you want to email me all the questions, I can answer them. And I've got a little a web page where I put kind of my frequently asked questions about the session, so I can use those to build that out. for sure.
Great. I will do my best to capture all the questions and forward them on to you. Yeah, hopefully we can take care of that. Again, I apologize, but I did not want to interrupt the presentation since we're running short on time. And
Yep.
thank you so much, Jason.
Yeah, thank you. Appreciate it. Everybody have
Thank
a
you.
great day.
You too. Thank you.